I'm out here in Lofoten, Norway, shooting the Northern Lights, which is one of the really cool parts about my job. Lofoten in Northern Norway is among the best places to catch a glimpse of the Northern Lights, and I've been lucky to capture several ones while I've been here. The Northern Lights are an incredible natural phenomenon where greenish or reddish light seemingly dances through the sky. If you're lucky to travel far enough north or far enough south, then you might be able to catch the auroras during the dark, long nights of winter. But even being in the right place during the right season doesn't guarantee a viewing. These tiny dancers can be difficult to find sometimes, which is why I will spend some time showing you the best ways to track down the auroras. We'll also learn what exactly these mystical lights are and where they come from, based on science and based on the people and cultures who have lived below their beauty for centuries. We have all seen images of the auroras, and you might even have heard that the auroras come from the sun. But understanding how they form helps us know how to have the best chances of seeing them. In the simplest of terms, an aurora appears when electrical particles coming from the sun collide with the Earth's atmosphere. The energy gathered from the sun and the long voyage heats up particles in our atmosphere, and that produces light. But how exactly do those particles appear, and why do auroras only happen at the poles? Well, to understand that, I'm afraid we are going to have to dive a little deeper into the science.
On the sun surface, you can have different eruptions. You can have eruptions of X-rays, energetic particles, but also as huge bubbles of charged particles, and these bubbles have their own magnetic field structure. These bubbles propagate from the sun to the earth in 1 or 2 days.
This bubble is called a coronal mass ejection, or a solar storm. And from this point, Kirsty suggested that we think of the process like a hockey match.
So you can imagine that the sun is like a hockey player shooting the hockey puck towards earth. First of all, you need to kind of follow whether the puck has a correct direction, so it's coming towards earth or is it going by. Well, if it is coming towards earth, then you need to follow how the goalkeeper is performing, and in this case the goalkeeper is our own magnetic field.
The Earth's magnetic field, the magnetosphere, acts like a shield and deflects some of those storms. Although auroras can only seem like a good thing, they can have harmful effects, especially in our modern world. Solar storms can damage communication and electrical equipment, so a lot of people actually don't want the storm to reach us. But from our point of view, we want the storm to defeat the goalkeeper. And those storms that make it through are transported down the magnetic field to the poles, where the magnetosphere is weaker. The charged particles that reach the poles end up bashing into gases in the Earth's atmosphere. The energy from those collisions is released as light, and we see that light as an aurora. Chasing the Northern Lights takes me to many countries. So I wanted to share an offer we've got for anyone wanting internet access overseas with the sponsor of this video, SIM Local. For those unaware, an eSIM allows you to keep using your existing SIM card, so all your usual phone calls and messages still work like normal. But then you can have a second electronic SIM that handles your international data at a much lower cost. With SIM Local, you can set up everything before you fly, so as soon as you land in a foreign country, you'll have internet access. I found this really useful for checking public transport information or hiring a taxi to my hotel, no searching for public Wi-Fi or looking for overpriced SIM cards in the airport. SIM Local operates in hundreds of individual countries as well as regional packages that allow country hopping around Europe. Their plans cover a wide range of allowances for different budgets and with a top rated Trustpilot score. Since you prepay, you can use your phone with no danger of spending more than you planned. So use the link below or QR code before your next trip and get a 10% discount whenever you use discount code BRIGHTTRIP. Alright, now let's go back to the video. Scientists believe that the auroras in the North and South poles are almost like mirror images of each other.
So if you look at the auroras from very far above, from a satellite, actually you can see the overall picture of the auroras from the southern hemisphere and from the northern hemisphere are in general similar. So the shape is like an oval shape, like a halo on the head of the angel.
This is called the aurora belt or aurora zone. And while the auroras are mystical and magical to us here on Earth, they're actually not uncommon in our solar system.
The critical thing is that the planet needs to have this magnetic field, so that kind of organizes the particles and you can see then the auroras. So examples of other planets which do have auroras are Jupiter, Saturn, Neptune and Uranus at least. And then there are some speculations that maybe in Mars you could also see a bit similar airflow as auroras. Auroras in the Earth are different from the auroras on the other planets in colors. So in Earth you can see these auroras with your naked eye, so they are visual wavelengths. While on